All right, so thank you. We are here today to talk about Knime and Python and how they can maximize, how you call it, data science, data analytics, data operations. Here I'm Paolo Tamagnini, I'm in the data scientist evangelism team. Here's with me, there is also Monty from the evangelism team as well, data scientist, and Carsten, the true product owner of the Python integration at Knime. So let's get started. So if you are new to Python, you should know that there is this big open source community of developers making all these packages that Python users like so much. We're talking about, for machine learning, scikit-learn, pandas to analyze data, matplotlib, numpy, and so on. So in an organization settings, you have usually a team that can use Python, as well as Knime, of course, to analyze data. Now, this is great. They can use all this free stuff. And the thing is that they can be also having to work with people that require their help, right, with all these amazing skills they have. For example, the marketing team wants to drive more traffic on the website, on the organization website, and or you have, for example, the finance team that wants to analyze a bit about their finance data. They hammer down with requests the data team again and again, asking more and more help to get their decisions from data insights, right? At the same time, probably the data team is also having to do with upper management on working on more complex projects, such as AI, like, I don't know, for example, a chatbot that can help customer care. Something that, of course, you can also measure business value from it. So there is a lot of work, of course, for the data team using Python and Knime, low-code, no-code, to be responding to all these requests, and at the same time, working on really advanced stuff, right? So the solution, of course, for this is to make workflows that can be given to all the rest of the company so that they become independent, right? They can go on with their analysis independently, regardless if there is Python adopted or not. And of course, when this is done, the data team has the time to support the decision makers on coming up with a complex plan on something really advanced and still for which business value can be measured. So with that, I would like to welcome now Monty to introduce us on an example on how you can build low-code workflows using Knime. So basically, we're going to see how you can build a Python analysis to measure geodistances directly in Knime Analytics platform using Python scripts, and the different ways to do this. Right, Monty?
Yeah, that's it.
All right, so let's get started.
OK, so hello, everyone.
Yep. This is later. First, the slides, some more, please. There we go.
OK, great. So as Paolo gave a fantastic introduction to low-code solutions, I'm going to walk you through an example where we build a low-code solution for a very simple and relatable use case. But the motivation here is to get you started, and then you could build more complex solutions. So while I go through this process of building low-code workflows, I'm going to visit these 4 topics. The first one is Python script node. And then we talk about using bundled packages, and then how we can encapsulate everything into a Python, the Knime component. And at last, let's talk about using custom Python packages inside Knime Analytics platform. So now, about the use case. As I said, it's a hypothetical one, but it's simple and relatable, which concerns to a pizza company in San Francisco. Now, this company has various delivery agents, and they are delivering pizzas across San Francisco. Now, as in this case, a delivery agent could start from the store location, and they might take any route to reach the destination and go on delivering pizzas. Now, this pizza company wants me to calculate the trip distance based on the location coordinates of this particular delivery agent. Now, let's see how this could be done. So when I look towards data, I see that there are 2 sets of data. First of all, I have trip details, that what is the route taken by a particular delivery agent. And in the second part, I look at the location coordinates of all the important locations in San Francisco. That means I have the longitude and latitude information, which I can use. Now, when I join this data, I get the entire set. Now it becomes much more easy for me to deal with this, because in one table, I get the trip information as well as the geographical information about the longitude and latitude. Now, I did a bit of research before I start this project to know how this could be done. And I know that there's a Haversine formula, which is used in many navigation apps and even Google Maps to estimate the distance between two geographical locations. Now, we're not going into the discussion of how this formula was derived, but I'm going to use this formula that I'm showing on the screen right now in my analysis. Now, if I were to use a Knime workflow to do this, I can use a bunch of math formula node and compute this distance. But now, if I decide to use Python or a Python snippet or in Jupyter notebooks, then I could use a small piece of code. And as I see that in Python, we have a package called as scikit-learn, which provides me with Haversine distance, a function which I could use. So by just writing a piece of code and then trying to compute the distances, I can see that I get the last column there, where I can see that the initial distance is 0, and then it goes on increasing towards the end of the trip. And this is how I can do it. But now, today, I want to build it using Knime and Python together. So to do that, first let's look at the Python script node. Now, the Python script node is already popular because I have seen many workflows using it, building awesome solutions. But just to give you an intro, this node executes on the local Python 3 environment. On top of that, it supports conversion of data. That means the Knime table could be converted into pandas data frame or PyArrows table inside the Python script node. Talking about the configuration dialog of this node, as you can see in the center, you could enter your script. And on the side, you can see all the columns that are available at the input of this table. And at last, we provide you a small console, which gives you warnings or errors, and also tells you if your execution is perfect. Now, moving towards low-code approach, what Paolo was presenting in the beginning, that we are using some kind of scripts in between the workflows to arrive at a solution. So in this case, the same problem statement that we are considering, in the first part, you could see that we are reading the data, that we are joining it and doing some pre-processing so that now this data is ready to compute the distances. Next, we have the Python script node, which we just discussed, and the same piece of code that I had from the Jupyter notebook. I am plugging it here. And as you can see, I can compute the distances now in this Python script node. Further, I have the round off node, which will try to round off these kilometers to last 2 digits, and then the table view. At this point, I'd like to move to the Knime analytics platform to show you a demo of this workflow. Yep. I think you guys can see my Knime analytics platform.
No.
Great. So this is the exact workflow that we discussed. And now, as I open up the Python script node, the dialog of the Python script node, you can see the piece of code that we had from the Jupyter notebooks is right here. And now, if I execute this particular Python script node based on the information of the delivery agents, it will take a couple of seconds, and even less than a second, I could say. And then when I look at the table, I see at last there's a column added, which is called as the trip distance column, the kilometers. So isn't it amazing that I'm using the Python package to compute distances inside Knime analytics platform? Now, the fantastic thing about this is, now if I share this workflow with anyone, or even on Knime Community Hub, they could execute this workflow irrespective of Python installation on their system. And how is this possible? So to talk about it, I like to move to the slides, which is my next point.
I
think, yeah, I have to switch on the screen. Yep, switching to slides. Yep, thank you. The next topic, which is about bundled packages. As I mentioned, that now you could build your workflows in Knime with Python, and you could ship them to any other users, and they don't have to worry about their Python installation. The reason is bundled packages or a bundled environment. So with Knime Python integration, now we provide you a default environment that gets installed to your system. And that is why when you want to use some of the popular or widely used packages, This is the list of packages. Now, the intention here is to provide you some packages to get you started and not to worry about which environment or which kind of packages I need. You can look at the list here. We provide these useful packages. First of all, if you want to do something with web scraping, then we have Beautiful Soup. On top of that, we provide some packages for machine learning. Also, we provide visualization packages, which is Plotly, Matplotlib, and Seaborn. Talking about visualizations, recently with Knime 4.7, we released the Knime Python View node. Now, this node is capable of creating all Python-based visualizations inside Knime Analytics platform. For example, in this slide, I show you that with the Python View node, I am using the Plotly package, which is available in my bundled packages. And I'm able to generate interactive visualization where I could select different house age categories, and I can look at those data points. Now, now here when I discussed the Python View node and the Python script node, can I use these nodes to build even better solutions? And that's why I'm moving towards wrapping low-code components in components. So the idea is, at Knime, whenever we build a functionality, we try to encapsulate it into Knime components so that we could share it because it becomes reliable, reusable. And that is why, based on this motivation, if you see in the workflow, there's a little bit change at the end. Instead of using the nodes, I have put these nodes into a component. And now I provide the configuration dialog where the users can select the columns. And after the computation, I also try to visualize the results. Now, to talk more about it, let's switch to Knime Analytics platform. Yep. So now this workflow has changed because, as you can see now, there's a component here. If I zoom into the component, you can see in the beginning, I provide the users the choice to select longitude and latitude information. On top of that, at last, I'm also adding the Python View node, which will be using Plotly-based visualizations to visualize the map. For example, if you look at the configuration dialog, I can select the latitude and longitude columns. And when I execute an open view, just waiting a couple of seconds for the view to open up. And now, as you can see, on the left-hand side, I get the information about the trip distance, where the trip started, where it ended, and what was all the total distance in kilometers. And at the right side, I can also see at the map view the route the particular delivery agent took to deliver the pizzas, the start point and the end point. Now, it also supports interactivity, which means now if I select a particular points, those points get highlighted in the table. This is just a simple example to show how interactivity is as well supported with these Python View nodes. Now, you could use this kind of interactivity to build various Knime Python-related dashboards or data apps. But now, moving back to slides, I will like to talk about the part about using custom packages. Now, as with every project, there are always some improvements or enhancement. And I did realize that now Python provides a new package called as GeoPy, and which is much more accurate in computing these distances based on the longitude and latitude information. And also it provides me distance in kilometer as well as miles. So isn't it it's better than the previous way where I was using these formulas. Now, I wanted to use this inside Knime and this platform, but when I checked at the list of bundle packages, GeoPy is missing. So now, is it possible to use this package inside Knime? So the answer is yes. And how do we do it? So I'm going to show you a 3-step process, which is very similar to what we did with the initial bundle packages. There are minute differences. For example, in step 1, I create a new environment on my system. And in this environment, I install all the packages that I need for the Knime and Python integration. On top of that, I install the packages that I need. In this case, I needed the GeoPy package, so I install the GeoPy package to this environment. In next step, as you can see, there's a new node added, which is called as the Conda environment propagation node. Now, what this node does is, there are twofold benefits of it. First, it tells the Python script node to use the environment that the user has selected, right? And the second point is that when I ship this workflow on Knime Community Hub or even to anyone, so this node will make sure that all the prerequisite packages, that means in this case GeoPy, is installed to the user system before the execution of this workflow takes place. So that's how it's easy to use any custom package, use this node, and then export your workflows to anyone so they can use this functionality. Now, on the right-hand side, as you see, I select all the important information, that means the environment name, and then I also select the packages that I need. And at last, I go to the next step, which is the Python script node. Now, in the Python script node, I tell it to switch from the bundled packages to the Conda environment that I'm using. In this case, the environment which uses GeoPy. Now, in the last step, in the final step, now I remove the code that was using the formula, and I replace it with the GeoPy package that I use. That's it. With these minute changes, I am able to use a new package, which was not in the bundled environment, and I'm able to build the solutions. So now, where to find these workflows? I showed you the demos. All these workflows are available on my space, that is trip to Knime Python world. Also, if you're new to the Python script node, you can get started with the Python script space because it has many examples. The intention here is to get you started and how to use it in different scenarios, and that's why we categorized it into 5 different workflows. So I'm here around, even in the lunch break. Let me know if you have questions. I'll take up on this Knime and Python.
All right, so before we take questions, let's move to the next example of today. So we have seen this first. It's an example, right, to how you can use Python and Knime together directly in analytics platform, but it's something else we want to show you yet. So a second example on how you can create, we already mentioned this in the previous talks, how you can create brand new Knime nodes in pure Python, right? So to understand exactly what I'm talking about, in case you're a bit confused, we have the Python developer that makes all these fantastic packages that require quite a bit of time, and then other Python users can reuse. Then we have the data expert that uses Python, these Python packages combined with Knime, right? And then we have the final user that doesn't know Python but knows Knime, and so it can use this functionality. What if then the Python developer can directly supply the nodes directly to the domain expert, whether it is finance, geodistances, whatever, he can provide this no-code solution directly to the domain expert. And here I would like to welcome now Carsten to go ahead with the next part of the presentation.
Thanks, Paolo. As you already saw a nice example by Monty before about computing geodistances with Python, now let's do a quick 10-minute version of putting this into a pure Python Knime node. And for that, well, what the node would look like is like this. Let's just build something where we have 2 input tables. One of the input tables has a list of cities, the trips that you want to take, here for instance from Bangalore to Kolkata and so on. And then the second table actually provides latitude and longitude information for all of these locations that we'll travel by. And what this node will do, again, similar to Monty's scripts that he showed before, we'll add a column that provides the distance of between those cities. And now, let me give you a rough run-through of the screenshot that I showed yesterday already, but this time looking a little bit more into detail. And even if you're not into Python at all, it might still be interesting because this contains some of the pieces that each Knime node has. So in what you see here, at the beginning are a few lines that configure the nodes. I just mentioned we have 2 input tables, and we have 1 output table, and obviously, but we start with something before that. We have the name of the node, and then each node has a type. Here it's a manipulator, but you could have learners and predictors. Maybe you've seen that the nodes of the colors of the nodes change depending on what tasks they produce, and that's exactly defined by this node type. You can provide an icon and a category. This is where in this node tree, in the classic Knime UI, you have this, how the nodes are, this node repository where the nodes are placed in categories. In the modern UI, these are the tags then. And then we go on, we have the 2 input tables, where you can provide a name and you provide the description, and I'll get to the description in a bit. The same you do for output tables, and here we do one more thing. We provide a view, because those Python nodes can automatically have a view similar to what Monty was showing before. And then now we get more to the meat of it. This was all the configuration. Now we have the class that provides this node, and this class here has a docstring, what it's called, like in Python, and this string there is actually used by Knime to put this into the node description. So you write this little bit of code, and it will automatically also document your node so that users will understand what you can do with it. The next 4 lines are parameters, because usually you want your users to configure the node. Same way as Monty was building it in the component, where you have the selection for the input and output columns, the input columns. Here you can do the same thing. We have 3 parameters that are column parameters that let you select an input column depending on what. So the user can say which of the input columns is the latitude, which is the longitude coordinate. And one more thing, the last parameter is a string parameter, so this will define the name of the output column. And then there are 2 methods that you need to implement. One of them is configure. Configuration of a Knime node happens every time when an input changes. So when you connect a table to the input port, when you change the input port, when you change the parameters. And then what this configuration needs to do, it needs to provide all the downstream nodes the information, how will the table look like after I've executed this node later. And that means you need to provide the columns that are in the output tables, which data types they have. And if there are other ports, like maybe a trained model, you also need to tell which kind of model is coming out of this. And once that has finished, you can execute your node. Execution is where you actually get access to the input tables or images or whatever you might have, and then you produce the outputs. And in this case of the node, the outputs are a table and a view. And to show you this more in detail, I would now switch to an example. So here you see we have this node, 2 input tables, and just before we do anything else, let me show you that it can run and that it produces an output table with this new column with a trip distance in kilometers. And I mentioned one more thing before, so let me reset the node. Even if it's not run yet, because configuration specifies the output columns, you can already get the specs, so you know what the output column is called, what data type it is. And now let's look at the code. This is the same code that I showed you before. The only thing that has changed is basically that the configuration has some more checks in there, and that the execution actually does something. In the screenshot before, it didn't really do anything. Now, in this compute distances method, this is where we have the function that Monty was talking about before. We have the Haversine distance to compute the output table. And then there's one more thing happening. When you execute this, you might have noticed there's a warning sign. So you can easily communicate everything like progress and so on between Knime and Python. And here we do set a warning that this node was developed by this guy. So is that really worthwhile having a warning for that? Not so sure. So you might have noticed before that executing this node is not super fast. It takes a while to think, and it takes a while to execute. And the reason is this is running in development mode. The cool thing about development mode is that we can change the code, and it'll be reloaded whenever we change anything. So let's make this warning even more scary. Oops. Wait. So if we save this, switch back here, reset the node, run it again, you'll see the warning message has changed. And now we can do even more. We can, for instance, change the view. Yeah, no, exactly. I wanted to show that view before. So when you open the configuration dialog, I mentioned we have these 4 parameters where you can select the location. This is in column city. Then you have latitude and longitude columns as input, and we have the output. Let's quickly change this and say that's not trip, that's our distance. And then we can click OK. This again runs configuration, as I mentioned before. Now when we execute this and look at the output table, you'll see this has changed. Now it's the distance column. You've seen that you can easily iterate on developing in your Python node and just going through the code, changing something, executing it again in Knime. So this is one part of what you need to build a Python-based Knime extension. There are some more configurations. Monty was talking about that you have a Python environment with the packages that you need to execute your code. That's obviously the same for Python node extensions. How you do that is we use Conda as tool to package our to package this Python environment, and you need to provide a specification for a Conda environment that should be used to run all your Python nodes. During development, you need to set that up yourself, but then you basically put one file next to it containing all those packages, similar to the Conda environment propagation node. And when we package your extension and send it to, or put it on the hub, then we will take care of this environment being installed on the user machines. And the other thing you need to have is a Knime YAML file, we call it, which just contains description, like what is the name of your extension, who developed it, what version, what license, these kinds of things. Once you have that, you're ready to share. And I mentioned this yesterday already. There are 2 ways how you can share it. One is locally with just your colleague, like when we were testing, I built something, give it to Monty, or putting it publicly on the hub, then we'll get there in a bit. But if I want to share this with my colleague, then we provide you with a set of tools, basically a command line tool and instructions on how to do that. You just need the folder with the Python code and these configuration files that I mentioned before. Then you need to set up a special environment, Conda environment, with all the tools that we need to build a Knime extension. And then you can build this. This provides you with a zip file, or you can put this on a shared network drive to share it with your colleagues. And then in Knime, you've probably seen this install new feature dialog. There you just can enter this new update site that we call it, and then you can install this Python extension. If you don't just want to share with Monty, but you want to share with the world, then talk to us. You need to make your code public on some Git so your Git repository public. We'll integrate that in our build system and build your extension, put it online on the hub. Yeah, and if you want to do that, please send an email to us or talk to Stefan and Steven, who you've probably seen at the Birds of a Feather table as well. And yes, that's pretty much it, what you need to do if you want to build your Python extension. We support this since Knime Analytics Platform 4.6, and we're adding more and more features because people are starting to try it out, and obviously they have more ideas what you could do with this, so we're improving the infrastructure. There's a blog post by those 2 guys, the 4 steps for your Python team to develop Knime nodes. The code that we've shown, well, not the spaghetti part, but everything else you can find on the GitHub repository, and yeah, look at the documentation or ask us.
All right, so just to wrap up, in case you you want to have a wrap-up and overview. We have seen a lot. I understand it might be a bit overwhelming, so a small wrap-up before we close. So we have different approaches on how you can use Knime and Python together. The first approach is simply using the Python script node with the packages that we make available. So that's easy. You just write a script of code with these packages, and you can just share the workflows. Anyone downloading this workflow will need to install the additional node, and then it will work. The additional step, if there is a package that is custom, that is not available by default with the node, right? With the Knime Python integration. In this case, you will need also to add this additional node and select the environment where you additionally install these extra packages. But when too many users want this, maybe it's time to implement an entirely new Knime extension with Python, like Carsten showed us, right? You can see here a node from the geospatial analytics extension, actually, that it does these distances. That's a good example where you make your Python code available as a node, and people using the node, they don't even know that it was developed in Python or Java. They don't care. They just use it just like any other Knime node, and they simply need to install your extension like it is normal installing extension with Knime Analytics Platform. So thank you. Now we cover all the different topics, and it will be now time for questions. Yes.
All right. Thank you, guys. I mean, it was really visible that Knime software is truly a platform for all data workers, from citizen data scientists that doesn't want to do anything coding, to data scientists and data engineers, and of course, to complete the end-to-end data life science cycle, we need to deploy that to the domain experts who can actually interact with it and take decision on it. So thank you very much. And with that said, let's invite the participants and the online community for questions. So the mic runners, do you have any hands that are up in the sky?
Yes.
Yes, perfect.
Hello, I have a question regarding the performance. How is the performance compared to the native Java implementations?
That depends on what you do. In general, I mean, Knime, the whole software is written in Java. So if you implement some piece of code in Java, then it can just run in the whole Knime environment. Python is a different programming language, and you need to start a separate process. This overhead you'll have at some point. And we need to communicate the data back and forth, but that's, as I said yesterday already, that has become a lot faster, so basically there's nothing happening there. And then, depending on what you want to do, Python is an interpreted language. It's not as fast. If you write everything yourself in Python, it's usually not as fast as Java in terms of execution speed, especially if you iterate over huge table. But most of the machine learning libraries that you use in Python, so pandas, numpy, scipy, all these kind of tools, or also if you go to the deep learning frameworks, they're all implemented in C or even on your GPU, and this is as fast as it can get. So usually the performance of number crunching doesn't really make a big difference. Or if you have GPU acceleration, then Python could even be faster. But yeah, if you write every little statement yourself in Python, then it's probably slower than Java. Does that help? Okay.
We have another question from the online audience, which is similar. This time it's not between a Java and a Python node. What is faster, a Python script node or a Python node? Carsten, do you know?
Well, there is... because we use the exact same infrastructure under the hood, there's no real difference. The thing is, if you use a bunch of Python nodes in your workflow, then we know which extensions you have installed, and so we know which environment they need, and so on. We don't know that for a scripting node. Then we actually cache a bunch of processes. So we start them earlier, so you don't see that startup penalty that I just mentioned. For a script node, you will have this startup penalty. For a new Python process to start. For an extension, this doesn't happen. And so a Python node could
slightly faster.
Could be faster.
All right.
Thanks, guys. Any other questions from the audience here? Yes. Live in Berlin?
Yep, there's one.
Yep, perfect.
Yeah, okay, sure. I have a question regarding debugging. Or is it possible to hit breakpoints in both ways? So if you want in developer mode or if you have the Python script node?
So in the Python script node, you can't really attach a debugger. But you can still use print debugging, or we have this feature where you only select the line of code and you execute that, so you can always look at the intermediate results that you get, which is for the size of a piece of code that I would expect to end up in a script node, that should be okay. But as soon as you go for Python node development, there you can remote attach a debugger, and that works really nicely. But it makes a lot of sense to stick to debug mode, because you can run because you were just asking about this. You can run the nodes without debug mode, but then we do this process caching. And if you change something in your code when you're in a debugging session and want to improve some bit of your code, then Knime won't pick this up immediately, and that's exactly why we call it debug mode. It will only reload your code on each execution if you turn this debug mode on. But then, you can remote attach a debugger.
Okay, but in the script, would I be able to hit a breakpoint, for example?
You would have to, in code, write, it's rather easy. For instance, in Visual Studio Code, the framework you would use is debug.py. You just say debugger breakpoint here, and so you will have to edit the code. Okay. Or if you have your whole setup working, then but you still have to remote attach. So because we start the process. The other thing is usually the way you would work in an IDE. Then the IDE starts the Python process, and that way it can inject breakpoints. But in our setup, Knime starts the Python process, so the IDE needs to first connect to that Python process, and then you can debug. Once you're attached, though, you can put breakpoints in your IDE.
Right.
Yeah, next one.
Thank you very much. So I have a question about the connection to the Conda environment. Can you have the connection to any Conda environment that I might have lying around on my machine, or you need to have some specific packages pre-installed on the Conda environment?
Do you mean more for node development or in the Python script node?
For example, in the Python script node.
So maybe Monty wants to answer this one?
Yep. So there are a set of packages that you require for the Knime Python integration to work. So we have those list of packages in our documentations. You could install them, and then you can use your own packages in that environment.
Okay, so if I have a pre-existing Conda environment, I need to recreate it with these additional packages that I need.
Yep, exactly. You could recreate, or in the same environment, use the packages that we have instructed, which we require for the communication to happen. And then you can use it inside your Knime platform.
Okay, thanks.
Yeah, but in the packages that we require, most of them you probably have, like Python, NumPy, Pandas are probably already there.
Yep.
We need PyArrow and some Py4j, but those usually don't conflict too badly with other packages.
Okay. I think that was it. So I do have one question for you, Carsten, as developer. I know you guys love to talk about roadmaps in development. So what can the community expect in the future when this comes to Knime and Python?
So as I said before, obviously we put this out there and people started using it, and also the geospatial extension is a pretty big one already that has been trying or testing what we've been developing pretty to the core, and there are a bunch of feature requests out there. So what we're currently working on is something that also some of you have asked me, is that we don't currently support having a database connection in Python and sending that to further Python nodes. Because right now we could start a Python process all the time, and a database connection needs to reside in one process. And to make this worthwhile, we also need to be able to access credentials. So the passwords that we have on the Knime side, because usually you have this configured, and you want then the database connection on the Python side to also use the same credentials. So we're actually working on this right now to get credentials into Python and then have a database connection or something like that you can pass between processes. And then, let's see.
Looking forward
I
to
don't want to
working
promise
on
too
this
much.
Okay, thanks.